Hello, welcome back to my channel. Today we are going to discuss on the summary for chapter 7, Geometrical Optics. Okay, so for this topic, there are 3 subtopics. The first one is the reflections of the spherical surface, and 7.2 is the refraction of the plane and the spherical surface, and the last part is the thin lens. Okay, so let us start. Okay, so geometrical optics describe how light travel using a ray diagram. It's also a study about the light properties such as number 1, reflection. Okay, reflection is pantulan for the spherical mirror. Okay, so for the mirror is the reflection, and the second part is the refraction, perembiasan. Okay, perembiasan, and usually it happens in a lens. Okay, so we look at the first part first, 7.1, reflection. Okay, so reflection is actually you already learned during the secondary school, where it's actually a pantulan. Okay, pantulan. Okay, so the reflection is a phenomenon where the incident light is bounced off when it encounters a boundary. Okay, so the law of reflection is the incident angle must equal to the reflected angle, and all the incident ray, reflected ray, and also normal all lie on the same plane. Okay, so you observe here, the incident ray here is actually the angle is similar with the reflected ray. Okay, so this is the angle, and the angle is between the incident ray to the normal line. This is the normal line, so we label it as I, the incident angle, and the reflected angle also is a reflected ray and the normal line. So this is R. Okay, where the incident angle and also the reflected angle must be the same. Okay, so this is for the plane mirror. Okay, next, let us look at the spherical mirror. Okay, so for a spherical mirror here, we have 2 types of spherical mirror. The first one is convex, the second one is concave. Okay, so convex is actually a mirror. Okay, it's actually a cembung. Okay, cembung, and then concave is actually cengkung. Okay, for convex mirror, it has a wider view. Okay, and for example, security mirror or a side mirror. Okay, so if observe here, the incident ray, it will reflect upward. Okay, it will reflect outward. Dia mencapar. Okay, outward. Okay, it will reflect outward. Okay, it will not focus on one point. Therefore, we say as this is a Therefore, it's actually a diverging mirror. Okay, diverging mirror meaning that it is actually mencapar. Okay, all the reflected ray is acting or reflected outward. Okay, therefore the focal length here, we say it is actually equals to negative because it's mencapar, it's diverging. Okay, and the characteristics of the image form, okay, must be virtual, upright, diminished. Okay, however, for concave, okay, concave, if you observe the ray here, okay, so after the incident ray, when it reflected, it will focus on one point at the focal point. Okay, so all the point here, the reflected ray, it will focus on one point. Okay, it will focus on one point. Okay, therefore we call it as converging. Okay, converging mirror, where converging mirror here is actually menumpu. Okay, menumpu. Okay, it will focus on one point. Okay, it will focus on one point. That's why we call it as converging mirror. So our focal length here, we will always assumes that the focal length is always positive because it's converging mirror. Okay, converging mirror, and this converging mirror actually it will enlarge. Okay, enlarge the image, and also it will focus on one point. Okay, so for example, usually we will use it in for the cosmetic mirror. Okay, because it will focus on our face. Okay, where we have the pimples. Okay, or the dental mirror where it will help the dentist to focus on our teeth. Okay. Okay, so for the concave mirror, actually we have depends on the situation. Okay, where we have 5 types of characteristics. Okay, depends on where is the object. Okay, if the object is greater than 2f, okay, therefore we will get the image real, inverted, diminished. Okay, if the object is placed equals to 2f, the image that we will get is real, inverted, same size. Okay, if the object is placed between f and 2f, therefore we will get real, inverted, magnified. Okay, and number 4, if let's say the object is placed at the focal length, therefore we will not get the image, meaning that the image is far away, is formed at infinity. Okay, and the last part is if let's say the object is placed smaller than the focal length, the image form will be virtual, upright, and magnified. Okay. Okay, so later in the next video, I will show you how can we get the image. Okay, so I will teach you how to draw a ray diagram. Okay, so please watch on the next video. Okay, so the equations that we will use for the mirror is 1 over f equals to 1 over u plus 1 over v. Okay, where r is the radius of curvature is equals to 2f. Okay, so this is the first equation that we will use for mirror. Okay, and the second equation that we will use is the linear magnification, where m is equals to negative. Okay, so remember here there is a negative. Negative. V is the image distance over U. U is the object distance. L equals to H image over H object. Okay, so the magnification here, if the value that you get is greater than 1, okay, meaning that it's actually magnified. Okay, if m is equals to 1, okay, meaning that the height of the image is equals to the height of the object. Okay, meaning that it's actually same size. Okay, if the magnification smaller than 1, meaning that it's actually diminished. Okay, here, even though we only have two equations, the first one is 1 over f equals to 1 over u plus 1 over v, and the second one is the magnification equation. Okay, so even though we only have two equations, but when you want to apply the equation, you must be careful with the sign convention. Okay, especially the value for f and also v. Okay, so we must alert where when f equals to positive, okay, it's actually we are referring to the concave mirror. Okay, so positive here is actually referred to concave mirror, or we can say it's actually converging menumpu. Okay, when f negative, okay, for mirror is actually convex mirror. Okay, it's actually convex mirror, or it's actually a diverging. Okay, mencapa. Okay, next is the value for the image form V. Okay, so for image form V, okay, for image form V, okay, if let's say the image form same side with the object, so this is a real object. Okay, meaning that because it's a reflection. So if let's say, okay, let's say this is the mirror. Okay, let's say this is our mirror. Okay, so if let's say, okay, for example, let's say this is the mirror. If the object come here and then reflected back, okay, if the image form is same side with the object, therefore it's actually a real image. Okay, but if let's say the incident ray and the image form is at behind of the object. However, if let's say the image form opposite side with the object, therefore this is actually a virtual image form. Okay, meaning that it's opposite side with the object or behind the mirror. Okay, and then we also have the value for m. Okay, when m here is the magnification. Okay, so here we have m. Okay, or we can say m or h image. Okay, so if the value that you get is positive, meaning that the image form is actually upright. Okay, menenggak, menenggak. Okay, whereas if the value for m or the image height we get negative, okay, meaning that the image form is inverted, terbalik or songsang. Okay, so these are the characteristics of the image form and also the sign conventions that you need to consider when you apply these two equations. Okay, so this is for mirror. Okay, next we'll go to the refraction. Refraction is pembiasan. Okay, pembiasan. So for refraction, first part we will go to the plane surface first. Okay, so refraction on the plane surface actually you already learned during the secondary school. So we just recall back. Okay, where if let's say this is the incident ray. Okay, this is the incident ray and the incident angle is between the incident ray and the normal line. So this is the incident ray. Okay, if let's say N1 is less than N2, meaning N2 is denser than N1, okay, the reflected ray here, okay, it will go nearer to the normal line. Okay, from less than to denser. Okay, where the incident angle is greater than the reflected angle. Okay, case 2 is when incident ray, okay, is incident from N1 to N2, where N1 is denser than N2. Okay, so from denser to less than, okay, the reflected ray will move away from the normal line. Okay, so this is the incident angle, this is the reflected angle. Okay, so from denser to less than, the angle of incident will smaller than the angle of reflected. Okay, and the equation that we will use for the plane surface is N1 sine theta 1 equals to N2 sine theta 2. Okay, so this is what you have learned during the secondary school. Okay, so for this level, we will learn the reflection at the spherical surface. Okay, so actually the theory almost similar, where here we have the, okay, here we have the spherical surface. Okay, so this is a spherical surface, okay, where the normal line here, okay, let's say this is the tangent, tangent to the sphere, okay, and the normal line must be perpendicular. Okay, so this is the normal line. Okay, this is our normal line. Okay, so the incident angle, okay, incident angle, this is our incident angle. Okay, incident angle. Okay, so this is our incident angle. Okay, so this is our incident ray, where the incident angle is between the incident ray and the normal line. Okay, so this one I label as I. Okay, if let's say N1 is less than N2, okay, therefore the refracted ray, it will move near to the normal line. Okay, so this is the angle of refracted. Okay, therefore the angle of incident will be greater than the angle of refracted. Okay, so the angle here is actually depends on from denser to less than, or from less than to denser medium. Okay, so for equations that we will use for the refraction at the spherical surface is N1 over U plus N2 over V equals to N2 minus N1 over R. Okay, so usually when you want to use this equation, okay, N1 here, okay, we always refers to the, okay, it depends on where is the object. Okay, where is the object? So usually where the positions where the object is at there, meaning that that is the medium, okay, that we will use it as a N1. Okay, and then R here, okay, we also have the sign convention. If let's say positive, okay, meaning that it's actually convex. Okay, if let's say negative, meaning there is a concave surface. Okay, so this one you must remember. Okay, next one, types of lens. This is for 7.3 is thin lens. Okay, so actually thin lens and mirror, there are two things that are different. Okay, the first one is convex mirror will become concave lens. Okay, or concave lens will become convex mirror. Okay, so meaning that it's actually opposite. Okay, and the characteristics for both actually the same. It's just that convex become concave, concave become convex. Okay, so last time for convex lens, okay, we will have the characteristics of the image form where if U is greater than 2F, you will get real inverted diminished. If let's say equals to 2F is real inverted, same size. Okay, if let's say between F and 2F, R is, if let's say the image is between, okay, if let's say the object is between F and 2F, so the image form will be real inverted and magnified. Okay, and the fourth one, if let's say the object is at the focal length, so it will be at infinity. And the last point is, let's say the object is at the position less than the focal length, therefore we will get image virtual, upright and magnified. Okay, so this is a convex lens. Okay, convex lens. Okay, and also this is also a characteristics for concave mirror, so it's actually opposite. Okay, okay, next, concave lens. Okay, concave lens, if you observe here, because it's reflection of pembiasan, so the incident ray, it will reflected outward. Okay, it will reflected outward. Okay, mencapak. Okay, mencapak. So it will reflected outward. Okay, therefore this one we call it as diverging. Okay, and the focal length here is negative. Okay, whereas if you refer back to the convex, okay, after incident ray, it will focus on one point. Okay, it will focus on one point. Okay, it will focus on one point. So when you focus on one point, this is actually a converging, menumpuk. Okay, therefore the focal length here should be positive. Okay. Okay, next is the image form for concave lens. Concave lens, okay, at any point, okay, no matter where is your object distance, okay, at any point also the image form, okay, must be virtual, upright and diminished. Okay, so if you observe here, actually upright it will pair with the virtual. Okay, if I say the image virtual, sure it must be upright. Okay, similar with in real, if I say a real image, the image form will be inverted, dia akan terbalik. Okay, so this is the first difference between the lens and the mirror. Okay, meaning that concave mirror is actually convex lens, and then convex mirror is actually concave lens. Okay, so it's opposite. The characteristics, everything will be the same for mirror and also lens. Okay, and the equation that we use also the same. Okay, the first one is 1 over F equals to 1 over U plus 1 over V, the first equation. And the second equation is M equals to negative V over U, or H image over H object. So this is the second equation that we will use for thin lens and also mirror. Okay, so these are the two equations that we will use for lens and also mirror. Okay, so similar, we also need to consider the sign convention. Okay, where V, okay, positive, meaning that it's actually a real image form. Okay, so what is the difference here between mirror and lens is, if let's say okay, so the incident ray, it must be reflected to the second medium. Okay, so that's why a real image form must be opposite side with the object. Okay, whereas for a virtual image form, okay, it must be same side with the object. Okay, so these are the two different. The first one is convex become concave, concave become convex. So this is the first difference. The second difference is the image form. Okay, for reflection, pantulan, for mirror, okay, the real image form is in front, okay, in front or same side with the object. Okay, whereas for lens, the real image form must be opposite side with the object. Okay, so these are the two differences. Okay, next we will go to F. Okay, similar F, still it is a converging for positive, converging menumpu. Okay, so for this case, for lens, converging or for lens, our F positive when it is. Okay, so for F, when F positive is converging, meaning that it's actually a convex lens. Okay, F negative, okay, F negative meaning that it's actually a diverging mencapa. Okay, so it actually is a concave lens. Okay, so for F, for H image. Okay, so both of them, if they say positive, meaning that the image form is upright. Okay, upright. If let's say you get negative, meaning that the image form is inverted. Okay, terbalik. Okay, so this is the sign convention that you need to consider. Okay, next one is the lens maker equation. Okay, for lens maker equation, we also can use this equation, equation number 3, to find the value for the focal length if let's say the radius of the lens is given. Okay, so the equation that we will use is 1 over f equals to n2 over n1, where n2 here is the material. Okay, material of the lens. Okay, the material, bahan yang kita guna. Okay, and then N1 actually is the medium. Okay, the medium that the lens inside. Okay, so R1, R2, it depends on it depends on what is the lens that you are using. Okay, so here we have converging and also diverging. So for lens, converging is actually refers to convex. Okay, so here we have biconvex. Okay, so if let's say biconvex here, the first layer of the first surface is actually convex, so it's positive R. Okay, and then the second layer, if you observe from left to right, is actually concave, so it's negative R. Okay, for plano convex, this is positive R. Okay, and then this is a plane surface, so when the plane surface R is equals to infinity. Okay, next is a positive meniscus, or we can call it convex meniscus. Okay, so this one is positive, and this part, the second layer, also is positive. Okay, next we will refer back to converging. So for this case, converging is a concave lens. Okay, it's a concave lens. Okay, so we also have biconcave, where biconcave, the first one, okay, the first layer is actually concave, so it's negative R. The second layer is convex surface, so it's positive R. Okay, plano convex here, this is a plane surface, so it's infinity. And then this part here is convex. Okay, so it's positive R. Okay, after that, okay, we also have negative meniscus, or we can call it concave meniscus. Okay, so this is positive R, and this part also is a positive R. Okay, so this actually depends on what are the value of the lens that we are used during calculation. Is R1 and R2. Okay. Okay, so another equation that we will use for the reflection of the spherical surface, okay, is actually the magnification. Okay, so the magnification, okay, the magnification for the spherical surface, okay, is actually m equals to negative n1 times v over n2 times u, or h image over h object. Okay, so this is another equations that we will use for the spherical surface. Okay, so that's all for this equation. Okay, so that's all for this summary. Okay, so please go to the comment there. I already shared the summary link. Okay, you can click and download it. Okay, so see you on next video.